AC distributor faded both ends faded both ends with uniform loading. Uniform loading. Okay. Okay. Now we will see what happens if it is same voltage. Okay. So let us take this point. Okay. In the same way, another line here. Distributor fitted both ends. So we have to write here one. And this is the another end. Okay. Now let us take the tappings here. Let us take few tappings. First one. Okay. So here so distributor fitted both ends with the okay. So let us take this is the one way of direction feeding here. Let us take this one as A, this one will be B. Students, can you hear me? So let us take the midpoint of the conductor. Let us take the midpoint of the conductor is C. Okay. And the total length here from this point to this point is total length will be okay. Here the total length will be equal to capital L, sorry, small l. Now from this initial distance A to this point, let us take this one as the small distance here, so that can be denoted by dx. Okay, from A to the small distance, let us take this one as the x. Okay, how can we find this distance then? Total minus this value, total minus this value. The total minus these two values will give you this the value between the dx c to b. Okay, total AB minus AC will give you the BC value. So this is nothing but okay, here. So this is the figure. So this is the distributor fed at both ends. Distributor fed at both ends with equal voltage. Equal voltages. Distributor fed at both ends with equal voltages. So this is the figure here. Figure is the distributor fed at both ends with equal voltages. Okay. Now let us consider here. Let us consider. Let us consider a point. Let us consider a point C at a distance of x units. At a distance of x units from the feeding point. From the feeding point. Okay. So what is the feeding point we have taken here? Is A. Let us consider a point C and A. Now let us find this the total on conductor, the total on current conductor, the total on current conductor AB. Total AB is I into L. I into L. Now current supplied from each end is current supplied from each end is I into from A it is L by 2, from B it is L by 2. So from each end it is I into L by 2. Okay. Now the total current at point C. Therefore, therefore, therefore the total current at point C. Total current at point C is equal to I into L by 2 minus I into X. I into X. That can also be written as IR into L by 2 minus X. So we have taken this for small dx length. So that will also be the multiplier. Now therefore the voltage drop, voltage drop between AC voltage drop between AC is integral over dV. Integral over dV. What is integral over dV means? I into R. So that implies integral will be taken from 0 to x distance. We have taken from feeding point A. We have considered x distance from feeding point A. So we have to take from 0 to x. Okay. Then this value will be taken as equation number 1. So I into R L by 2 minus x into dx. Okay. Now, now let us do the integration part now. That implies here we are integrating with respect to dx. So other variables will be taken as constants. So we will be writing outside the integration. So I into R by 2. Sorry, let me write here clearly. I into R divided by 2 into L into x into x square by 2. Okay, is that clear for everyone? Okay. We should also substitute the limits also. Therefore, the maximum voltage drop will occur at midpoint. Therefore, 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 the maximum voltage, maximum voltage drop, maximum voltage drop will occur at midpoint. Will occur at midpoint. Okay, that is x is equal to L by 2 at the midpoint. Okay, substitute the value of x. Therefore, maximum voltage drop, maximum voltage drop, maximum voltage drop, maximum voltage drop, that is V max is equal to wherever x is there, substitute there. Sorry, this will be minus Lx minus x square by 2. Okay. So wherever x is there, there you have to replace it with L by 2. Okay. Now maximum voltage drop I into R by 2. Open the bracket here. L into what is the value of x? Okay. L into L by 2 minus L by 2 whole square divided by 2. Is that clear for everyone? Okay. Therefore maximum voltage drop, maximum voltage drop, maximum voltage drop is equal to I into R into L square divided by 8. I into R into L square divided by 8. So this is the final value. Okay. Then we can also write this in this way. I into R into L square can be L multiplied by L. Okay. Sorry. Divided by 8. Okay. That implies I into, we can write L on one side and into R into L divided by 8. That implies I into L can also be written as capital I into R into L can also be written as capital R divided by 8. Okay, where I into L is the total current distributor. That implies capital I is equal to what? Small I into L is the total current of the distributor. Total current of the distributor. Total current of the distributor. Okay. And next, capital R is nothing but small r into L will be total resistance, total loop resistance. Total loop resistance. Okay. So therefore, the maximum voltage occurring at midpoint is V minus I into RL square divided by 8. Therefore, let me write this one. Therefore, minimum voltage, therefore, minimum voltage drop, occurring at midpoint is total voltage V from A side minus I into R into L square divided by 8, or else we can also write this as V minus IR divided by 8. Okay, so let me put this in a box. Okay, hope you understood that. This is very important. Okay, let us take an example. Yes. So let us take this example over here. Okay. The solution will be here. So let me highlight what is the given data here. A uniformly distributed load on a distributor having a length of 500 meters is rated at 1 ampere per meter length. The distributor is fed from one end. Okay, distributor is fed at one end at 220 volts. Determine the voltage drop. Determine the voltage drop at a distance of 400 meters from the feeding point. Assuming the loop resistance is how much? 2 into 10 power minus 5 ohms per meter.